Cody Schwartz, and I'll be speaking about Immutable.js, which is a JavaScript library for creating and working with persistent data structures. So the goals of the talk, I want to give you a sense of the value of using immutable data structures, and then also getting started with Immutable.js. So what do we mean by immutable? Well, immutable means that once a data collection is created, it cannot be altered at any point in time. Any time in the future, that one data structure will always be the same. You cannot mutate it. So why is this interesting? Well, using immutable data structures and pure functions can make application development a lot easier. You can reason about your code a lot simpler. And this is well aligned with state management practices in React using flux principles. And actually very well aligned with Redux, which requires persistent state trees in the reducer, which really Immutable.js is a perfect use case for that. So again, why is this interesting? So problems caused by mutating objects. So mutation hides change. So if one function method call in your application mutates an object that another part of your application is using, it has no way of knowing. And so where it's relying on a certain data property, it might not be there and it might be different. Also, the result of any method, if you're not using pure functions with immutable data, the result of any method requires on the state of that object and the arguments that go into that function. And then these objects that require, these methods that require a lot of state are hard to test because you need to set up your testing. You need to set up state to then run the method to make sure that it's doing the correct thing. And then also just adding features in another part of your app, I guess as I mentioned before, that can change a data property on one of the objects that you're referencing in another part of your app to cause that to break. So you really, as your app grows, there can be almost a spider web of different methods that are changing your data. And especially with a lot of developers working on an app, it can be hard to know where some bugs might be coming from. So if we start building apps with immutable data and pure functions, what sort of benefits are there? Well, the UI or the view level is very predictable when it is just a pure function of the application state. For those that are familiar with React, the React render function is supposed to be a pure function where it gets data and it renders a view. Data in, view out. It also, again, a React thing, but it enables simple change detection within your component. So the component method should component update. The easiest way to do that is say basically does the props you have now equal the next props, or one object equal to object 2. If it is the same, then you don't need to re-render. If it's different, then you re-render. And likewise, it's also easier to test. So you don't have to load up state. You can just load into your function a data structure, and then is the output predictable. And again, it's less likely to cause bugs in your application because your one data structure cannot be changed anywhere else in your application. And then by doing this, you can also write independent code. These are pure functions. You can write independent code that can be taken from one part of the application and brought to another and reused. So we're both building, again in React, building components that can be used throughout the application, but also functions that can be used throughout the application. So now that I've sold you on using Immutable.js and immutable data structures, let's talk a little bit about Immutable.js. So Immutable.js is immutable persistent data structures that leverage structural sharing. So what does that mean? Well, as we talked about, immutable means data that's once created, it can't be altered. Persistent means that new collections can be created for mutation of the previous collection, but that previous collection is always there. And then what's most interesting really is this structural sharing. So it's not achieving this by copying everything. It's making the minimal changes necessary to create a new object. So if we have one big object, we make one change, to create a new object, those two objects are going to reference a lot of the same underlying objects. And so it's much more efficient in both a speed to calculate and create those objects and also memory management, not as much garbage created. So let's do a little Immutable.js in action. So very simple to bring into your application. You just import npm install it, import immutable from immutable, or you can also just add in a script tag and use a CDN or load it in using your script tag. So now we'll just do a little bit of a demo. So Immutable Maps. So Immutable Maps are basically the equivalent of a JavaScript object. And you actually generally start them by loading in a JavaScript object. So easy to bring in. You just bring in the map from Immutable. And then here I'll just show you some examples. So we set up a map by just putting in a standard JavaScript object, wrap it in a map, and that creates an immutable map. But again, so now Immutable can't use the same dot notation or bracket notation to access the keys in the values. You need to use basically get and set. So set is to change a key and value, but again, you're not changing it on that original object. You're returning a new object with that property changed. So in this example, if we do map1.set b to 50 to create map2, now map1 property b is equal to 2, key to b is equal to 2, while map2's key b is equal to 50. Right? So one simple change, we have two different objects. Map1 stays the same, but now map2 is different. But again, just to drive home the structural sharing point, they're both going to point to that same A1 and C3. So map3, we can just also merge in JS objects. Map1.merge in a new object creates a new map. Easily, bring in new properties. So maps also are more interesting because they have iterable methods. So many of the data structures in Immutable are also iterable, which means you can use a lot of your favorite array methods on them. So here we'll create a new map, alpha, with 4 key and values. And then we're going to map over that map. And so here's a simple one. We'll just turn each key to uppercase and then join them. And so we turn this map with all those keys and values into this string ABCD. We can also filter, another favorite array method, and return a new map which filtered out anytime the value equals 2. So the equivalent of JavaScript arrays are immutable lists. So you can create a list just by putting in an array to set up a list. And again, you use set or get instead of bracket notation. So we're going to set index 2 equal to 5. So now if we get index 2, it gets 5. And this is on the new object or the new structure. And then some methods that we know to be very mutative. So pop or push, we know those just either remove something from an array or push something into an array. Those, again, in immutable land don't do that, but they create a new data structure with the equivalent if that had happened. So a.popc returns 3, just like the pop method does, but a remains the same. A.push, we push in 4 to create d, a remains the same with just those 3 numbers. So Immutable also plays nice with JS, as you saw. To create the list or the map, you just put in a standard JavaScript array or object. And you can create nested immutable objects very easily. You just do from JS and wrap that nested JavaScript object to create a nested immutable data structure, which can be maps of maps, maps of lists, so it knows what to create. You can also back convert anything from immutable. Say part of your application you want to just use immutable, but in other places you're not going to fully transition to immutable data structures. You can back convert to JS using to array or to object, or again for nested data structures to JS. You can also return a JSON object using JSON stringify. And of course, all of this would not mutate the original data structure. You create a new data structure by doing this. And so there's also some other interesting immutable data structures. There's an ordered map, which, as we know, JavaScript objects don't have a specific order. Nor does the standard immutable map, but the ordered map, based on the order in which you put key and value pairs in, that is the order it's going to have. The stack, like we all love from Foundations, or I guess early at full stack, the standard old stack, putting values on top. And there's some other interesting ones. Range, you can create collections of numbers based on certain properties. It's an interesting structure. So I guess further resources on Immutable. I thought what was really interesting is the Immutable source code. You can dig in there and see how they implemented all this. It's just plain JavaScript to do this. And we did this with our binary search trees and linked lists. So they did the same thing to create these maps and lists, and it's pretty cool to see. And there's a great Egghead series for getting started that can, if you're interested, take you a little farther than beyond the get and set methods that I showed you today. So that is it. Thank you for listening and learning about Immutable.js.